Hello everyone, my name is Rick van Bruggen from Neotechnology, and here I am again recording another episode of the Graph Database podcast. And today I've got a guest all the way from the US, Karl Urich. Hi Karl.
Rick, very nice to speak with you.
Thank you for joining us. It's always great when people make the time to sort of go on these podcasts and share their experience, their knowledge with the community. I really appreciate it. So, Karl, why don't you introduce yourself? Many people won't know you yet, so you might want to change that.
Yeah, absolutely. So again, thanks for having me on this podcast. It's really great to be able to talk about the things I've experimented with and really see if it resonates with people. So I own a small consulting business called Datafoxtrot, started under a year ago. Primary focus of the business is on data monetization. If a company has content or data, how can we help those companies make money or get new value from that content or data? If they could be collecting data as a byproduct of their business, or they could be using data internally in their business, and then they realize that someone outside the company can use that as well. So that's the primary focus of my business. But like any good consulting company, I have a few other explorations. And really this intersection of the world of graph and spatial analytics or location intelligence is what interests me. And so talking a little bit about those explorations is what will hopefully interest your listeners.
Yeah, absolutely. Well, so that's interesting, right? I mean, what's your background or your relationship to the wonderful world of graphs then? How did you get into it?
Yeah, so, going all the way back to college, I did take a good introduction to graph theory as a mathematics elective, but it then really got into the world of spatial and data analytics. For 20 years working with all things data, demographic data, spatial data, vertical industry data, along the way building some routing products, late 1990s, early 2000s, products that did point-to-point routing, drive time calculations, multi-point routing, really kind of that original intersection of graph and spatial. So I'm a data junkie, very interested in data, graph, spatial, data modeling, etc.
Yeah, cool. And I understand that this spatial component is like your unique focus area, or at least one of your focus areas these days, right? Tell us more about that.
Yeah, absolutely, and it's certainly what resonates when I think about the graph side. Spatial data. It really should define spatial data could be any sort of business problems related to proximity, location, or deriving things. Because you know where something is, your competitors, your customers, the people that you serve, and that's what resonated to me when, as I started to look at graph and spatial, I was really excited back in April. I walked in just very coincidentally in a big data conference to a presentation being put on by Cambridge Intelligence. And so they were introducing spatial elements to their graph visualization. So,
absolutely. They just released a new product, I think, right?
Just released the new product. At the time they'd gone beta, and so that really got me thinking about how could you combine graph and spatial together to solve a problem, looking at Cambridge Intelligence's technology, looking at some spatial for Neo. And, again, my company is a consulting company, and if there are, if there's a need for that expertise at the intersection of graph and spatial, we want to explore that.
Very cool. Did you do some experiments around this as well, Karl? Did you sort of try to prove out the concept a little bit?
Yeah, absolutely. So let me talk a little bit about that. So I had this concept of a combined spatial and graph problem that looked at outliers. Outliers just meaning things that are exceptional, extraordinary. And the thinking is, in my mind, was businesses and organizations can get value from identifying outliers and acting on those outliers. So maybe an outlier can represent an opportunity for growth by capitalizing on outliers, or bottom line savings by eliminating outliers. So, let me give an example of an outlier. If you look at a graph of all major North American airports and their flight patterns and put it on a map, you could visualize that Honolulu and Anchorage airports are outliers. There are just few other airports that, quote unquote, look the same, meaning same location, same incoming and outgoing flight patterns. And that's really relatively easy if you have a very small graph to visualize outliers. But if you want to look at a larger graph, hundreds of thousands, millions of nodes, what would you do? So that really started the experiment. I was looking around for test data. Wikipedia is fantastic. You can download 50 gigs of Wikipedia data. I love Wikipedia anyway. It seemed very natural. And the great thing is that there are probably around 1 million or so records that have some sort of geographic tagging.
Oh, do they? Okay.
So a page, London, England, has a latitude, longitude. Tower of London has a latitude, longitude. An airport has a latitude, longitude.
Of course,
you could tease out all of the records that have latitude, longitude tagging, preserve the relationships, and shove that all into a graph. So you have a spatially enabled graph. Every XY has or every page has a latitude, longitude, or XY.
Yep.
So really then the hard work started, which was taking a look at outliers. So, a quick explanation of outliers. So you think of a Wikipedia page for London, England, a Wikipedia page for Sydney, Australia. They cross-reference each other. Pretty unusual, 2 locations, other side of the world. But would you call those outliers? Not really, because there's also a relationship between the London page and the Melbourne, Australia Wikipedia page. So you really wouldn't call those anything exceptional. And so what I built was a system. Just a very brief explanation is that I looked at relationships in the graph, looked only at the bidirectional or bilateral relationships where pages cross-reference to each other, and then really identified how close every relationship was to another relationship, or looked for the most kind of spatially similar relationship. You can score them then, and you can kind of rank outliers. So let me just give one quick example. It's actually my favorite outlier that I found. Which kind of an unusual thing to say. There's a small town in Australia called Urich. I think I'm pronouncing that right.
Okay.
That has a relationship with a town in the Sinai Peninsula called El Urich. And Urich in Australia is named after El Urich, Egypt, because Australian soldiers were based there in World War I.
No way.
Yep, and most importantly, this relationship from a spatial perspective looks like no other relationship. So that's the kind of thing when you are able to look at relationships, try to rank them in terms of spatial outlier.
Yeah, sure. Yeah.
Yes. You can find things that lead to additional discovery as well.
Super cool.
As a Wikipedia junkie, that's pretty fascinating.
Very cool. Well, I read your blog post about it, and outliers made me think of security aspects. Actually, I don't know if you don't know the book Liars and Outliers. Yep. It's a really great book by Bruce Schneier. And I also had to think about we recently did like a wiki challenge, which is like finding the connections between Wikipedia pages. How are two randomly chosen Wikipedia pages linked together, which is always super fun to do. Super.
Oh, absolutely. It was even in my original posting. I didn't want to say that, hey, this could be used for security type applications. So I think I talked in code and said you could use this to identify red flag events.
Yes.
But I like to think of it as both the positive opportunity and the negative opportunity when you're able to identify outliers
But identifying outliers has lots of business applications, right? I mean, those outliers are typically, very interesting, right? Whether it's, in terms of unexpected knowledge or, fraudulent transactions, suspect transactions, outliers tend to be really interesting, right?
Absolutely. Absolutely.
Super cool. So where's this going, Karl? Where do you think, what's the next step for you, with Datafoxtrot, but also, graph technology in general, any perspectives on that?
Yeah, well, so there's a more of a tactical thing, which is as we record this a week from now, we have Graph Connect. Probably,
I'm so looking forward to it.
Which will be fantastic, and being able to test this out with people. It's always great to bounce ideas off of people. In terms of next experiments, the one that interests me is almost the opposite of outliers, and let me explain. So I have some background in demographics and analytics and segmentation. So what interests me a lot is looking at clustering of relationships in the graph. Yeah. And so clustering, think of clustering as grouping things that are similar into bins or clusters so that you can really make kind of overarching statements or predictions about each cluster. And you can use techniques like k-means to do the clustering. And so what interests me about graph and spatial for clustering is you can use both elements, the relationships of the graph, the spatial location of the nodes together to drive the clustering. So, if I've started some of the work on this, again, using Wikipedia data, and maybe the outcome using Wikipedia, if you did your clustering based on spatial location of the nodes, plus strength of the connection, plus the importance of the nodes, plus maybe some other qualifiers, like if a node is a Wikipedia page for a city or a man-made feature, a natural feature, you might end up with clusters that have labels to them. One cluster might be all relationships connecting cities in South America and Western Europe, or relationships between sports teams around the world. So it's kind of the opposite. If outliers is finding the outliers, the exceptional things, clustering is finding the patterns. And you can think, real world example might be an e-commerce company is looking at their distribution network, and they want to do clustering based on shipments, who shipped what to whom, where the shipper and recipient are, package type, value, other factors. And they could create a clustering system that categorizes their distribution network, and they can look at business performance by cluster, impact of marketing on clusters, and sometimes just the basic visualization of clustering just often yields those eureka moments of insight. So that's kind of the next interesting project that's out there. I'd say ask me in like 6 to 8 weeks.
We'll definitely do that. You'll definitely do that. Cool. Karl, I think we're going to wrap up here. It's been a great pleasure talking to you. Thank you for taking the time. And, I really look forward to seeing you at Graph Connect. And, I wish you lots of, fun and success with your projects.
Excellent. Thank you very much, Rick. Really appreciate it.
Thank you. Bye-bye.